Welcome to Automated Visual Software Analytics. This part is about software maintenance. We will explore different models for the software lifecycle, and we will have a look at different aspects of software maintenance, in particular on adaptive maintenance, corrective maintenance, preventive maintenance, and perfective maintenance. Let's start with the software lifecycle. The software lifecycle denotes a formal model of the way software is being developed. It's also called a framework or even a methodology framework for software development. There are different software lifecycle models or methodology frameworks around. The most traditional one is a waterfall model. It defines a number of stages: requirement analysis, software design, software implementation, verification and test, and finally maintenance. It defines these stages and they are ordered in a linear way. So software should be developed by handling all these stages, and as a result, the software should be operational, fully functional, and it should have certain software qualities. Of course, the waterfall model is a traditional model and not really up to date, because during the last decades we find out that software development has a more dynamic nature. This dynamic nature is represented, for example, in the spiral model. It says basically we start with analysis, evaluate our design, develop implementations, and we do further planning for the next cycle, for the next iteration. There's also a key method around that aims at rapid prototyping. At prototyping software systems, we determine our objectives, develop, refine, and demonstrate, and we end up with testing and implementing artifacts. So there is a large collection of methodology frameworks around, and maybe in your team, in your project, you have defined which one you take. There is not a unique or best practice model around, although today many software development teams use agile methods or Scrum techniques. During the software development lifetime or life cycle, regardless of the concrete methodology you are using, we can identify certain stages in all these frameworks. It's the initiation stage, when we begin and we want to identify needs. The concept stage, where we start sketching and forming models of our software system. The planning stage, where we start to make more precise models, specifications, requirement analysis, how to find out what customers really want. The design stage, when things start to be more concrete and get specified in terms of formal languages, codings, or models. Then the development stage, when we convert a design into a complete system, including its environment, creating and testing databases, preparing test cases, etc. Finally, integration and test, when part of the system are already operational and we start to test it, to run the system. Implementation phase, when things get done and ported to the real environment. And operation and maintenance, it's in these large number of stages at the end, which describes tasks to operate and maintain information systems in a production environment. And finally, the disposition, that's the end of a system when it gets retired. In this model, maintenance appears to be just one stage in the lifetime. Reality is different. In reality, software maintenance, this part, is a key part because it takes most likely many years, even decades. So while these are the stages done in the beginning of a system very intensively, somehow maintenance hides the fact that during maintenance all these stages are repeated and repeated, because maintenance means that the system evolves, and evolution means that it's extended. So what we can see here in this model of the life cycle of a software system, that formally operations and maintenance appear to be just one stage, but practically operations and maintenance represent key part, major part of the lifetime of a software system. So whenever we talk about methods, techniques, tools that improve software development, we should focus on the maintenance phase, because this is a major phase in the lifetime of a software system. Let's go into details. What is maintenance? Maintenance is defined as the phase where you have any changes to a system after it became operational. Maintenance can be differentiated according to different goals, to different objectives that are behind maintenance activities. One key direction of maintenance is called preventive maintenance. That means increasing the maintainability or reliability to prevent problems in the future. Maybe problems that did not already occur, but they are likely to occur. So if we prevent problems in the future, if we, for example, increase software quality, then it's called preventive maintenance. Another key dimension of maintenance is called adaptive maintenance. That means everything that is done to modify the system in order to cope with changing software environments, adding new functionality, and adopting new requirements from the client or from customers. So adaptive maintenance is a daily business in the evolution of complex software systems. Corrective maintenance has a clear goal. It's about correcting faults, diagnosing and fixing bugs, etc. Whereas perfective maintenance aims at improving performance, maintainability, or other attributes of software quality, including functional enhancements. Though what we see is that maintenance has different motivations. In reality, sometimes these motivations blend into each other. So you can never be clearly differentiate between, for example, preventive and perfective maintenance, because sometimes, and in many real projects, these different aspects are merged and form a complex motivation to enhance a system after it became operational. So that's software maintenance. And now the really interesting fact about software maintenance is that it's a key factor in terms of costs and time in software development. Maintenance costs are increasingly growing, especially if systems become aged. If we talk about legacy systems, then the maintenance represents a major stage in the software lifetime. It's estimated that about 90% of software lifecycle costs are related to the maintenance phase. If we look at this fact, and about 90% means that it differs according to the type of software system or the branch of the software system, its domain. But more or less, a major part of budget is spent for maintenance. But if we take this as a fact, then we can ask, well, do we have the right tools, techniques, and methods for software development if these tools, methods, and techniques focus on the initial phase instead of the maintenance phase? What we will find out and what we will explore in the other parts of this course is that there is really a need for better tools and techniques and methods that handle and support the maintenance phase of software systems. This is maybe one of the key weaknesses of today's software engineering, that it's not really focused on the maintenance phase. However, if we look in the future, we can already foresee that maintenance will become the central issue in software development. So in general, maintenance constitutes the largest part of the software lifecycle costs, more than 2/3, and about 60% of the maintenance costs are generally related to program understanding and comprehension. Program understanding and comprehension means how can we get aware of a piece of the complex system? How can we enable developers to transform, to modify, or to change that piece of the whole system? To do so, developers need to have information about this part they are dedicated to. And they have to understand and comprehend how it works. Think of having an old system and a new developer that starts to get involved. How can this developer become aware of the underlying models, dependencies, structures, or behavior that is related to that piece he should or she should modify or transform? So program understanding and comprehension is a key issue. It's a crucial aspect of software effectiveness. So if we talk about how effective is our development process, program understanding and comprehension should be supported. It's a large issue for any aging legacy system, and of course it's the key target of software analytics. The question for program understanding and comprehension has been investigated by a number of software engineer researchers in the past. And as David Parnas points out, changes made by people who do not understand the original design and concept almost always cause the structure of the program to degrade. So if program comprehension and understanding does not take place, it is very likely that any changes and modifications done to the system will cause the software system to degrade. After many such changes, the original designers no longer understand the product. Maybe they are not anymore working for the company. Those who made the changes never did. In other words, nobody understands a modified product. So program understanding and comprehension represents a key issue for software maintenance, for effective software maintenance, and it's a key task to be supported by visual software analytics. Let's summarize the findings of this part. The software lifecycle is faced by the enduring, long-lasting maintenance phase. And it does not depend from the concrete framework of software development methodology. Whatever you use, you will have a long maintenance phase if you develop, for example, a legacy system or if you develop any complex software system. Software development effectiveness takes effect during maintenance. That is less relevant to the initial construction stage. It's relevant to the maintenance phase. Software analytics is a key instrument and approach for the efficient management and handling of software maintenance. Of course, it can be applied also to the initial phase, but its true value resides in the maintenance phase. Software analytics enables and simplifies program understanding and comprehension as required by almost all maintenance activities and tasks. So software analytics is a key instrument for all these issues we find during software maintenance. And software maintenance is, in a sense, a reality of software development. Sometimes in literature and science, it's not reflected too much and it's not seen like this, but if you look at the time spent in developments, in industry, you find that software maintenance is a key issue there because it takes years, it takes decades. Let's summarize key terminology of software maintenance regarding the software lifecycle and adaptive, corrective, preventive, and perfective maintenance. The software lifecycle is a period of time that begins when a software product is conceived and ends when the software is no longer available for use, so-called retirement. The software lifecycle typically includes a concept phase, requirements phase, design phase, implementation phase, test phase, installation and checkout phase, operation and maintenance phase, and sometimes the retirement phase. According to the methodology, these stages that are described here are arranged at a time axis. If you, for example, use agile methods, then you have several iterations and these stages are repeatedly done. The software product represents a complete set of computer programs, procedures, and possibly associated documentation and data design for delivery to a user. Both definitions are taken from the IEEE glossary on software engineering. The software maintenance as a key and dominating phase in the development of legacy systems and big and large systems or complex software systems, defines a process of modifying a software system or component after delivery to correct faults, improve performance or other attributes, or adapt to a changed environment. The process of retaining a hardware system or component in or restoring it to a state in which it can perform its required functions. Of course, we focus on the first definition because we talk about software systems, we talk about analytics for software systems. The 4 dimensions included in maintenance are summarized here: preventive maintenance, aiming at increasing maintainability or reliability to prevent problems in the future; adaptive maintenance, that aims at modifying the system to cope with changing software environments, adding new functionality or adopting new requirements; corrective maintenance, that aims at correcting faults, diagnosing and fixing bugs; and finally, perfective maintenance, that aims at improving performance, maintainability, or other attributes such as functional enhancements. So make sure that you understand these different 4 dimensions or motivations for maintenance as a characteristic catalog of activities done during the maintenance stage. Further reading, I recommend this article, The Economics of Software Maintenance in the 21st Century, if you want to know more details about the relevance and the dynamics behind software maintenance. I also want to give you some remarks. The term maintenance is ambiguous and has a number of connotations that sometimes hides the fact that it represents some major time span in the life of a complex computer-based software system. Actually, sometimes it has even a negative connotation because maintenance is shaped by several other industry processes and it's not considered to be a creative phase. Software engineering, however, software maintenance is just a name for the long time after the initial construction of a software system. So make sure that you have this different meaning in your mind, that you can distinguish between maintenance of, for example, physical systems and maintenance of a software system. If developers would have the choice, if I would have the choice, I always would like to prefer to build a new system, selecting new tools, thinking about new structures, maybe sketching a new architecture, using a new programming language or new features of programming languages, new libraries, new coding styles. If I would have the choice, I would prefer to build new systems, but that's sometimes a dream, because if we start working in a big company, most likely we will not have the chance to create a new system from scratch. So software maintenance and effective methods are really relevant for this important task in software engineering. So in reality, more people already modify existing computer-based systems than writing new ones. Yeah, tools and techniques for efficient maintenance become more and more key to industry, like software analytics. This is where software analytics comes in. It aims at supporting program comprehension, program understanding, and on analyzing different quality aspects of a software system, helping developers to be more efficient and to be more effective during software maintenance.